Number one, you're on the beach in Galveston, Texas at 2 p.m. on June 15th. The tide is in. The water level is at its deepest. At the time, you find that the depth at the end of the pier is 1.5 meters. At 8 p.m., the same day when the tide is out, you find that the depth of the water is 1.1 meters. Assume that the depth of the water varies sinusoidally with time. 8. Write an equation expressing the depth of the water in terms of the number of hours that have elapsed since 12 noon on June 15th. So they're not actually asking you to graph. That's not a requirement, but let's go ahead, illustrate what we have so far.
Okay, here's what I have so far. So what I did was first kind of made a quick illustration to translate what the direction that's been given to us into a simple diagram. So at 2 p.m. we hit our biggest depth, so it'll be our maximum, and then our minimum would then fall to 1.1. So then our graph, after looking at this, I went ahead and plotted my points and simply drafted a very simple cosine graph. And I noticed that from 2 p.m. to 8 p.m., we are hitting our maximum and our minimum. So therefore, it's only half of the full cycle, right? So I went ahead and created the other half in red. And I noticed that since it took about 6 hours from 2 p.m. to 8 p.m., that for us to complete the full cycle, it would take full 12 hours. So at 2 a.m. the next day, I'll be hitting the maximum again, which is 1.5. So based on this graph, I went ahead and determined our amplitude period. Our amplitude would be 0.2 because it's 0.4 divided by 2. Our midline is 1.3 because I did 2.6 divided by 2. And then we have a vertical shift, obviously, thanks to our midline. And our horizontal shift would be -2. And our period is 12. And I determined that by looking at the period of our parent cosine function divided by p equals, it takes 12 hours to complete a full cycle. So therefore, our p will be pi over 6. So this is a function equation that I came up with based on what we know. And to solve for b, I simply substituted t equals 4 into this equation and used a calculator, and what I end up getting is 1.4 meters. And then for c, what we have to do is we have to take a look at how many times, how many hours passed since noon all the way up to 7 a.m. on June 16th. So it'll be starting at 2 a.m. Starting at noon until 2 a.m. there's 14 hours, and from 2 a.m. to 5 a.m. there's 2 a.m. to 7 a.m. I don't know why I put in 7 a.m. It would be 19 hours. This should be 7 a.m. There's 19 hours in total, so I just went ahead, substituted t equals 19, and what I end up getting is about 1.13 meters. And now D, they're asking, when does the low tide occur? Low tide is literally what they mean by low tide is when the water level is at its minimum. So the last time we hit our minimum water level was at 8 p.m. And so if you think about it, I hit my maximum at 2 in the morning, so it's gonna take me another half a cycle, which is 6 hours, So our next low tide would be at 8 a.m. And that's it, really. It's quite simple, isn't it?
And our next question reads, when a spaceship is fired into orbit from a site such as Cape Canaveral, which is not on the equator, it goes into an orbit that takes it alternatively north and south of the equator. So that means it's going up and down, alternatively north and south, right? Its distance from the equator is a sinusoidal function over time. Suppose that Discovery is launched from Cape Canaveral. And Cape Canaveral is not on the equator, right? So it's going to first go, it's going to travel horizontally first, and then it's going to do its up and down thing. 10 minutes after liftoff, it reaches its furthest distance north of the equator for 1,000 kilometers. Half a cycle later, it reaches its furthest distance north of the equator. I'm just repeating myself, right? Half a cycle later, it reaches its farthest distance south of the equator on the other side of the Earth, also 4,000 kilometers. The Discovery completes an orbit every 90 minutes. Let y be the number of kilometers the space shuttle is north of the equator. Consider distances south of the equator to be negative. Let t be the number of minutes since lift off. Okay, so if I can graph it, I think what they want us to do is first, they want us to sketch the graph. So since we are starting off at 4,000 kilometers north, that means that's going to be our maximum, right? And then it's going to travel south and it's going to hit 4,000 kilometers again. So that's going to be negative 4,000 since we're going south. So we would have a cosine function like this, and we know that this is where the liftoff happens, correct? And it takes 10 minutes after initial liftoff. So I'm going to go ahead and indicate 10 over here. And the cycle, it orbits every 90 minutes. So that means 90 minutes is when we complete the full cycle. So 90 plus 10 would be 100. And 110 divided by 2 would be 55. So 55 is when we reach our minimum, and which is negative 4,000, and at 100 is when we reach our maximum, thus going back to one full cycle. Okay, so now we can go ahead and organize our information. So our amplitude would be 4,000, and our vertical shift, or we can take a look at our midline. Midline would be just 0, so therefore our vertical shift is non-existent. And horizontal shift is 10, so it would be negative 10, correct? And our period would be 2 pi divided by p equals, it takes 90 minutes, so 90. That means p would be 2 pi divided by 90, which is pi divided by 45. Okay, with that information given to us, I can write my equation to be y. We have to use y because we're expressing y in terms of t. So it would be y equals 4,000 cosine pi over 45, and then t minus 10. This is what I have. So you can decide to use cosine function too, as long as we are able to get this right. So, but what I have is y equals 4,000 cosine pi over 45 times t minus 10. Okay, and then now all we have to do is find out the spaceship's distance from the equator when it's t equals 163, which means all we have to do is substitute. So this is question B, this is question C. Let t equal to 163, and then what I end up getting is 4,000 cosine pi 45, 153, and if I plug that into our calculator, I get negative 1,236. And negative in this case just means it's going south, right? So that makes sense. So this is what I get, negative 1,236, and negative just means south. So 1,236.07 kilometers south. And then the next question reads, hey, calculate the distance of Cape Canaveral from the equator by finding y when t equals 0. So what we can do is simply substitute 0 into our equation again. So y equals 4,000 cosine pi over 45, negative 10. And if I put that into a calculator, what I end up getting is cosine 3,064.18. .18 kilometers. And this time it came out positive, which means it's north. That's it. Yay. And let's move on to the third question. Number 3, you're on board a submarine submerged in the Pacific Ocean. At time t equals 0, you make contact with an enemy destroyer. Immediately, you start porpoising. I didn't know the word porpoising. Learn something new every day. Porpoising, which is going deeper and shallower. At time t equals 4 minutes, you're at your deepest, 1,000 meters below the surface. Let the surface of the water be y equals 0, and at time t equals 9 minutes, you're at your next shallowest point, which is 200 meters below the surface. So it looks like this graph would be reflected graph, correct? Because we're working with something that's below water level. So let's see. I'm gonna again draw a quick graph. At t equals 0, okay, immediately, all right, at time t4, you're at your deepest, which means you're hitting your minimum, right? So 1, 2, 3, 4. Your minimum, and our minimum is 10,000 meters below the surface, so it means negative 1,000. Hi.
Oh, okay.
So, anyway, and we go up at t equals 9. You're at your next shallowest point, 200 meters below the surface. So 4, 5, 6, 7, 8, 9. Which is 200, negative 200 is shallowest point. So okay. So this is the graph that I came up with. Negative 200 is actually our shallowest point, meaning closer to our water level, and negative 1000 is when it's at our deepest. So this is at our 9-minute mark, and 4-minute mark. And again, they didn't tell us when it comes back down, but we could tell from looking at our time that it would take about 5 minutes for it to go up and down again. So the full cycle takes about 10 minutes, right? Okay, now based on that, we can find our amplitude, which is 400. Our midline is at negative 600, and our horizontal shift is at 1, 2, 3, 4. So it'll be negative 4. Vertical shift will be negative 600, which is the midline. And our period would be 2 pi divided by p equals 10. So it'll be 2 pi divided by 10, which is pi over 5. So we can write our equation to be they want us to use, okay, depth would be y. So y equals 400. But if you think about it, it is a reflected cosine function. So it'd be negative 400, and then pi over 5 t. And there's horizontal shift, so it'll be minus 4, and then midline, negative 600. This is what I have after taking everything into an account. Okay, and now we can answer the following questions. Your submarine is safe from the enemy destroyer when it is 300 meters or more below the surface. Was your submarine safe at a time t equals 0? Justify your answer. When t equals 0, so we substitute t equals 0, and then what I end up getting is negative 4.
Aren't you Arso?
I am?
Yeah.
Oh, I did not know that.
Okay, so I went ahead and drafted my graph for question number 3, which was the submarine question. And this is the graph that I drafted, and I realized that from its deepest point to the shallowest point, it takes about 5 minutes. So therefore, our full cycle happens in the span of 10 minutes. And based on that, I found out that our amplitude is 400. Our midline is also negative 600. Our horizontal shift takes place in positive 4 units. So therefore, this is what we would have to write down next to x, like this. And then for a period, I know that the full period takes about 10 minutes, so which means our full period would be pi over 5. So based on that, I went ahead and drafted this graph, and there's minus there. It's totally up to you. You can go ahead and decide to use this point as your starting point, which means our horizontal shift would have happened until 9. So this is one option. Another option would be using this part, which would be then y equals 400 cosine pi over 5 t minus 9 minus 600. This should do as well. And based on this equation, when t is 0, I substituted 0 into our equation, and then what I get is negative 276.39. Therefore, it is not safe because the question says that we are only safe when we are 300 meters or more below the surface. So since this is bigger than negative 300, we're not safe. And then they also ask you for question D, they want us to find between what 2 times is your submarine first safe. So I substituted y equals negative 300, and I would have to go ahead and use arc cosine or inverse cosine function on your calculator. And after I performed all the operations, I get about 7.85. But then it says they want us to find the 2 times, right? So if I take a look at my graph, about 7.85 is around here. If this is 8, 7.85 would be somewhere around here, right? And if you think about it, we can extend our graph because they wanted us to find the first 2 times, right? And our graph is cyclical, such as this. So what I would have to do is, since I know that this should be about 7.85, and we know that our graph is symmetrical, so therefore another point, equivalent point right here, would give us 200 or more. That would be our threshold, correct? So what I end up doing is I ended up calculating the distance between the two. So 7.85 minus 4 would be 3.85. So the distance from 7.85 to 4 is 3.85, which means I would have the same distance on the other side, and that happens to be 0.15. So therefore, the 2 times are 0.15 seconds and 7.85 seconds. Now let's move on to number 4. Number 4 says, as you stop your car at a traffic light, a pebble becomes wedged between tire treads. When you start off, the distance of the pebble from the pavement varies sinusoidally with the distance you have traveled. The period is the circumference of the wheel, and the diameter of the wheel is 24 inches. So for this question, one thing, it's kind of like the Ferris wheel question. So I went ahead and drew this wheel. This wheel is our tire, and let's say our pebble is stuck here. So when it travels around the entire circumference, that's about 24 pi, right? And since we know that the period is the circumference of the wheel and the diameter of the wheel is 24 inches, and
because we know that the diameter of our wheel is 24. So if, let's say, our pebble is stuck on the ground level, 0, when it goes up, the highest point it would reach is 24 right here, correct? So based on that, I drafted this graph, yeah. And if I were to take a look, it says we can find out that our amplitude is 12, our midline is also 12, and our period, they gave it to us, it's 24 pi, which means we would put, where is it? Oops. We will put P equals 24 pi, therefore 2 pi over 24 pi, which is 1 over 12, and that's what we would have to put into our cosine function. So after I did all of that, what I end up getting is y equals 12 cosine 1/12 x minus 12 pi. There's a shift, horizontal shift of negative 12 pi plus positive 12. And then from there, I went ahead, substituted the value 35 for question C to get 23.70. And then for D, though, similar to the submarine question, I used inverse or arc cosine to find out that x is 57.55. And I identified 57, well, I kind of approximated it. You know, I identified 57.55 over here, which means there should be another point, symmetrical to this point. So again, I calculated the distance between that point to our midpoint, which would be 12 pi, and then subtracted that same amount from 12 pi. So I get 17.85 inches. Yay. Hi.